We have this saying that data is your moat. Protect your moat, build a moat around your moat.
Moat squared.
I would like to know more about this double moat, please.
Sorry. You can just go right through the giggles. That's just
Yeah, keep going.
ignore them.
I'm just going to mute Nick when he laughs too much.
I did double moat. I mean, it's funny. What, you want me to be quiet?
Here we're going to talk about 3 features, so maybe it's a triple moat. I don't even know what that would look like. Like
Oh,
one's
God.
one's got crocodiles in, one's got sharks, like one's got stingrays or something.
Hello, and welcome to OverArchitected with Nick and Holly, where together we're experts on AI and data engineering, but we are missing security.
So in this episode, we thought we'd do something a little bit different, and we would bring on a security expert to talk through security features. So I'd really like to introduce Andy Weaver, who is a security expert here at Databricks. Hi, Andy. How are you doing?
Hey, doing good. Thanks for having me.
Andy's really happy to be here to help us with this, and we've definitely not forced him into it. So we thought we'd do something a little bit different this month because it is a quieter month because of the holidays. Instead of talking about features that came out for the last 30 days, we actually are going to start off with an architecture. And with Andy's help, we are going to go through some of the best security features at Databricks and improve our architecture to make it far more secure. So we've got some ingest from some various data sources. We've got just kind of some buckets, some SQL Server, some various kind of data sources. We then have some data in bronze, silver, and gold, and we're doing that with kind of external tables and managed tables and a mix of serverless and non-serverless compute. We also have a bit of AI in there as well. You can tell I made this because I've got no idea what that does specifically. And then with that final data, we then want to put it into a final place for people to use, and that's a Power BI dashboard and some Delta sharing, maybe putting it into Lakebase and then putting it into an app. And I think in our prep notes, we said we wanted to have something like a retailer as this example, but candidly, I think this looks like a lot of people's architecture that they might have in their company. Andy, do you want to take us through the first thing that is wrong with our architecture and how we could improve on this?
Yeah. Tell Holly it's bad.
There's a lot of things that you would use to secure your Databricks workspace that aren't necessarily called out specifically on here. So it might be the case that and some versions of Databricks, you get some of these things for free. So like, for example, if you're using Azure or GCP Databricks, then you get single sign-on configured like for free. So you don't necessarily that's just kind of like uniformly applied. But if you're using AWS, then it is something that you have to configure.
Sorry, I'm going to stop you there. This is not a bit, I am so bad at security. What is SSO? Why do we care about it? Why do we like it?
We talked about earlier about the retailer scenario, and part of the reasons that we discussed that was because this year in particular there have been a number of kind of high profile hacks and attacks against specifically UK retailers. I'm not sure what groups have against the UK or its retailer companies. It strikes me that if you want to be like a digital Robin Hood, there are probably better targets to go after.
No, steal from the co-op. Do it.
Yeah.
This is editing Holly here. In case this isn't abundantly clear, this is a joke. Do not steal from the co-op or any other supermarket, or just don't steal, okay?
First stage, the attackers target getting hold of your credentials, and they often do this via things like phishing attacks, vishing, which is like phone based.
And sorry, when you say credentials, you mean like the login details, right? So your
Yes.
username and your password.
Yeah. So generally the first kind of step that they would try and do is get hold of your username and password so they can try and log into your resources. The next step that they often have, the hurdle that they then have to overcome, is that most companies now have multi-factor authentication configured. And then the third step is, once they've kind of like overcome these hurdles, what can they do with those credentials? And so I often try and bucket like the security features that we have into 3 kind of main goals that they're designed to meet. So the first is making it harder for the bad guys to get access to your credentials in the first place. The second is making it harder for them to use your credentials if they do get access to them. And the third one is, like, we have this saying that data is your moat, right? So like, protect your moat, build a moat around your moat, if that makes sense. But yeah, build a moat around your data.
Moat squared.
Yeah. But yeah, and so SSO is single sign-on. It's the idea that rather than like us having to like have usernames and kind of passwords all over the place, that we have an identity provider that manages the access to our applications, that kind of manages our username and password on our behalf. You don't need to have a different username and password for each app, and you don't always have to enter them. Like when you log in the morning, then you sign in, and then from then on you can kind of like just browse all of your apps.
So, Nick, can I hand it over to you? Can you add SSO to our diagram?
Yeah, just to confirm, SSO stands for super secure something.
Yes.
Super
Come on, guys,
secure.
that was supposed to be funny.
Yeah.
Work with me here. Well, it applies to our entire thing. So can I just make a huge like? Is this okay?
Well, it's not going to cover the non-red stuff. So the red stuff is like Databricksy things.
Oh, okay. Well, we need
Uh,
Databricks. We need Databricks somewhere here then, Holly.
well, that's
Okay,
like the red stuff.
okay. The red stuff.
What I would kind of do is,
Yeah, Andy, walk me through this.
yeah. So can we expand out the Power BI, the Delta Share, and the app to give us a bit more room, and then we'll apply the single sign-on box to the stuff like left of that. The most privileged activities that we're doing, the building of the data, like using AI on the data, putting in a lake base, and all of that stuff is going to be done by the end users of our organization. So yeah, so
All right.
that looks good to me.
Part of my ignorance, so like multi-factor authentication is part of single sign-on as well.
Yeah, so I would add plus
Um,
MFA, so single sign-on plus MFA. So one thing that's important to note is that if you bring your own identity provider, then most customers will configure multi-factor authentication within the identity provider. We do have on AWS specifically, we do have the ability to offer multi-factor authentication through Databricks. But where Databricks is natively integrated with Entra ID and Google Cloud Identity, we like that feature isn't available because most customers would just configure it there anyway, which they'll be doing across their like kind of like cloud platform.
sorry, the multi-factor authentication, that's where you like get a text message or like an email to be able to log on.
And oh wait,
Username and
I have a question, Andy. No, go ahead. Sorry. I'll
I was
ask
just going to
later.
say, I was just going to say, the idea is that a username and password is something that you know, but a multi MFA prompt is something that you have. So it's like a phone. So it kind of is the idea that it strengthens that username password combination by like if someone had to like stole your credentials, they would also potentially need access to your phone in order to log on as well. What was your question, Nick?
My question is if there's any difference between SAML, like the different protocols that you enable for single sign-on.
I would say SAML version 2 is like historically what most people used. OIDC kind of gained in popularity. I think it might have been Facebook that came up with the OAuth protocol, but it's gaining in popularity. From a security perspective, I think most people consider them to be reasonably equivalent. OIDC and OAuth by extension has the advantage of like they thought about kind of like how you apply this to like token based access, and so more and more organizations, so it's not just about user like logins, it's also about programmatic access, and so more organizations are starting to move towards OIDC. But from a security perspective, I think most people consider SAML version 2 and OIDC to be like secure.
Okay, all right, cool.
Oh, and then so programmatic access is a really interesting point because we've got Power BI here as well.
Mhm.
And so I think I've only ever set it out with a PAT token before, but I think there's other ways that you can do it now as well.
Yeah.
You're going to tell me that's wrong?
Um, So there are ways that you can make PAT tokens slightly better, such as I think now you can configure like maximum lifetimes on the like, so you can set up a rule with the token management API that says a user can create a PAT token, but it has to be rotated every 30 days, basically. So Again,
Okay.
making it harder for the bad guys to get access to your credentials, because if they do, they've got a narrow window with which they can use it. Generally, if you're using Power BI and you're an Azure customer, then we support essentially like user-based federation, so you can log in with your Entra ID credentials to Power BI, and then the benefit of
Okay.
that is there's no kind of like passwords or anything knocking around. The alternative for customers on other clouds is to use essentially OAuth tokens. OAuth is preferred to PAT because it generates, under the covers, it generates tokens that are only valid for an hour. If your token, your credential somehow gets into the hands of the wrong people, you're kind of narrowing that time window in which it can be used by them.
But what happens if I'm using Power BI for longer than an hour, though? Does it like rotate it on my behalf if I'm using Entra ID? Or so it just sets it up and it does it, and you don't have to do your own key rotation, and so you just set it up once and that's it done?
Yeah, and it's the same with OAuth. So OAuth has been designed as a protocol that automatically generates these short-lived tokens in the background, so that you don't have to keep on kind of like logging in or changing them. It just does it on your behalf.
Maybe there's something else we should mention about PAT tokens. If you are going to use them, you should not be pasting them in plain text into any of your code. And if you work at Databricks and then you check that into a repo, all of these alarms fire off and you get really nasty emails from people telling you that you're really incompetent. Don't ask me how I know. It's definitely not first-hand experience. There's a secrets feature, isn't there, where you can have like secrets and then the scope of the secret. That doesn't necessarily like negate some of these elements, and you still have to rotate them manually. But yeah, don't do that.
My pet tokens are literally everywhere. They're in my like Apple Notes app.
I think we've changed it now, but way ago at Databricks, you could create a PAT token that was valid for like 9,999 days or something. So, like now, I think now, as we've kind of like hardened the security posture, I think maybe the maximum is something like 90 days. And if we have loads of stuff going on behind the scenes.
No, it's more. I know.
More. Okay. So
it's like 700 something. It's like 3 years.
So importantly, like we have added a load of stuff both behind the scenes that customers might not be aware of and that they can leverage to make PAT token usage, like allow them to monitor it better so that people like Nick don't do like that. In the account console, there's now a PAT token report kind of dashboard that you can go to, and you can look at all of the tokens that anyone's created on all of your workspace, see that Nick's created one that's valid for 700 days and revoke it and stuff like that. So we also, as a kind of like to help customers prevent them from shooting themselves in the foot, behind the scenes, we clean up PAT tokens that haven't been used for 90 days. So Nick, if you haven't used your PAT token in 90 days, it may not even exist anymore. We might have done that tidy up for you.
I literally misplaced them. So I figure security through obfuscation and, you know, if I don't know my tokens, nobody else can know them.
Is that also Andy's next security feature is if you don't know it, no one else does. But what about using credentials?
So this is like the next big thing. And actually like some of the attacks that we've had this year have shown like, and the year previously, not mentioning any names, have shown the real importance of like this as an additional control. The reasons why is that actually like hacking groups like the group that declared war on UK retailers, have shown that they're really good at bypassing MFA and single sign-on. The way that they often get access into these organizations is that they call the help desk for that that company, and they do social engineering so that they find out enough about someone to be able to pass the security checks and like unlock their username and passwords. They then move on to the multi-factor authentication piece. At Databricks, we have like these things called FIDO2 keys, which are like physical, like they use like biometric fingerprints to essentially identify them as us. And so like it's a stronger authentication than just an MFA that you just acknowledge on your phone, for example. The problem with the MFA that you acknowledge on your phone is that these hacking groups have shown that basically if they spam someone for long enough, they're more likely to just be like, leave me alone, and just say, okay, I accept the prompts. And then the problem is that gives the hacker access because they've got the credentials. Where these kind of additional controls, like we're going to talk about, like IP access lists come into play, is that even at that point, if Databricks is configured to only allow connections from specific like trusted networks, even at that point, although they've got the credentials and they've passed the like multi-factor authentication tests, they still can't actually log into the workspace, because when they try to, we'll say like, no, you're not from a trusted network. So they then have to try and be able to get onto the customer's VPN or something like that, which just adds another kind of barrier.
All right, so IP access lists, I have no idea how I'm going to draw this. And we can say that if it's kind of like from the office, what's the broadest? Like, do we see like a geography for people working from home, or do we see like a country, or?
Yeah, usually with IP access lists, they'll allow lists like connections from their office and their VPN. So they'll have like a VPN that's installed on all their laptops. They wouldn't often go to the granularity of specific countries. That kind of access is possible more often with front-end private link.
All right, so how is that different from a front-end private link?
Front-end private link essentially makes the end-to-end connection between your users and your Databricks workspace over private networks, essentially. So these are like dedicated kind of tunnels between your users and like from your on-prem office to the cloud and to Databricks. From a security standpoint, I think like most of the time it's probably overkill for a lot of customers, but some customers have like just a company policy that everything has to be over private link.
You spoke earlier about a moat and then a double moat. I would like to know more about this double moat, please.
Sorry. You can just go right through the giggles. That's just, I did double moat. I mean, it's funny. What, you want me to be quiet?
So here we're going to talk about 3 features. So maybe it's a triple moat. I don't know. Like maybe it's I don't even know what that would look like. Like
Oh, God.
One's got crocodiles in, one's got sharks, like one's got stingrays or something. So I guess the first thing that I would say about this architecture is we're using serverless compute to like transform our data and then serve it like via AI and lake-based to our app. We would recommend for customers like as an additional protection, so like kind of like building a perimeter around all of your data to configure serverless egress controls. So these would be kind of like that serverless compute. It would wrap them in effectively a distributed firewall that would allow your users to write to your managed tables, for example, but wouldn't allow like a bad actor, if they got hold of your credentials, if they were able to use them, to write them to like a public S3 bucket, say, and kind of like dump your data out to the internet where they could try and ransom it back from you or sell it to dodgy organizations.
I don't know how to add that to the diagram. I mean, it's like, I'm trying to find a metaphor for how to think about it, right? So it's like it's like ABAC, but for IP lists, right? It's like I have my IPs and now I have some extra stuff for IP access lists. Is that fair?
I guess we split kind of IP access lists as being ingress-based controls. So these are how people connect into Databricks, whereas serverless egress controls are about how serverless connects out. They would probably wrap this kind of, can you see that?
And now I know why my response was so clueless. It's because I thought we were talking about context-based. Never mind. Now I realize what we're talking about. That's my fault. Go ahead, add it.
I would say something like this. We would call this.
That's perfect. I mean, you're better than me at it. I'm out of a job now. Andrew, you are the new co-host of
Yeah, he's got a
OverArchitected.
guitar in the background and everything. Nick doesn't
Yeah.
do that anymore.
I've been angling for this for a while, Nick. You don't know, but I've been like studying all of the previous sessions.
Yeah.
All right, so that's all serverless stuff and writing out to various places. So in terms of setting this up, do you have to like specify the places where it's allowed to go to? So it's like allowed to go within my account, or it's allowed to go like within Unity Catalog, and that's fine. Is it a flexible wall that you can choose what are the levers that you pull to change that? Like, is it IP list? Like, I'm still quite confused by it in practicality.
Sure. Yeah. So we try and make this as easy for customers as possible. And we automatically add like
Mhm.
your Unity catalog locations, for example, to that perimeter, and like any kind of like connections that are internal to Databricks where a service needs to talk to a service. The only thing that the customer has to do is essentially something that gets added on top. So if they configure serverless egress control, it's based on this network policy, which is created at the account level. And you have two modes of operation for the network policy. It's either dry run, in which case it will allow any additional connections through, but it will log them to a system table so that you can see what the effect of that policy would be. Or you can add enforce. If you add enforce, then by default, you'll still be able to access all of your Unity catalog data because that's within your perimeter. But if you try and access any S3 buckets that are not part of not part of your Unity catalog architecture with storage credentials and stuff, then they'll get blocked. And similarly, if you try and access like any like network locations, like gets data from a REST API or something, that will get blocked as well because you would have to specifically add that to your network policy.
Oh, so it counts for data reads as well as data writes.
Yeah.
I think I was a bit confused about that because I thought it was only writes, but no, it's any movement of data.
Yeah, it applied at any kind of
Interesting.
outbound connection. So in order to read or write logs, it needs to make an outbound connection, and it will just like serverless has kind of inbound like protection by default in that it's in a private network. The private IPs aren't exposed outside of that network. We only allow connections from the control plane, so you can't come inbound to serverless anyway. And so serverless egress controls apply specifically for outbound connections, and any kind of read or write would make an outbound connection. And at that point, we would say, like, should this be allowed, and block it or allow it.
Okay, so I think that was like moat number 1. What is moat number 2 with the alligators?
Essentially, most cloud services allow you to configure things like, for example, an S3 bucket or an Azure storage account, some kind of concept of a storage firewall, which allows you to basically at the storage layer approve kind of like connections from specific networks. And so from here with serverless, for example, you can configure a private link endpoint within serverless, and at the storage layer say, I'll only allow connections from that private link endpoint. And so again, it's kind of like an additional layer that the bad guys would have to kind of compromise in order to access your data.
So am I drawing this right? Is it so it's a setting for these things, and then you have to set that up to connect to serverless?
So you create the private endpoint in serverless, and then you essentially add that endpoint to your S3 buckets. So the private endpoint kind of sits in the Databricks serverless network. We create that specifically for your customer, and we only allow like your workspace's compute to connect to it. And then customers can then add the actual endpoint to their storage firewalls, their S3 bucket policies to say only this private endpoint can access my data. And one of the kind of scenarios where we've seen really bad breaches in the cloud before are where things like S3 buckets have kind of had credentials that have been lost, and this is basically IP access lists for this S3 essentially, or front end private link for S3. It's controlling what can connect to my S3 bucket and ensuring that if these S3 buckets, if someone in my AWS account, say for example, accidentally generates like an access key for these S3 buckets and that gets leaked onto GitHub, and then someone has access to that, they still need to be on like an approved network in order to access it.
So it's one thing to like lock everything down, and that's fine if you just work with people that are in your company and they've all got the same logon and yada yada yada. But what about sharing data with third parties? So we've got things like in Power BI here, which does kind of have access, but also things like an app as well. So if you build that within Databricks, but you wanted to share that app wider outside your organization, you've got to collaborate at some point, right? Like, how do you not kind of like dig yourself into a hole, into another moat, the wrong kind of moat, shall we say, and you want to still be able to share data?
So maybe if we move the app outside the green kind of thing, this is now kind of, it's in our domain, but because like the partner isn't managed by our identity provider and like isn't on our VPN, we need different controls for these. And let's say we do the dashboard, the Delta sharing, and we do the Power BI app. So this is specifically the use case that we built context-based ingress for. So context-based ingress is kind of like IP access lists, in that you basically bring a set of allowed IP addresses from that represent networks that you trust, but probably don't have the same trust level as your office or your VPN. And the context-based part is that IP access lists are pretty like broad, right? They're not really identifying more than what location you're coming from, whereas context-based ingress kind of adds like the who, the why, the what. And so you can create rules that say this group of users from these IP addresses can only access Databricks apps, for example.
Okay, so there's kind of like IP address, an office, and then also like user-based as well, or groups-based.
Yeah.
So you have to be a certain person as well as in a certain location.
Mhm.
What are your thoughts on our architecture so far? Have we dramatically improved it now?
Ultimately, it's very hard for someone to say that they're like, like hack proof, but it's possible to say that if someone is going to hack us, then they're going to have to swim through a lot of moats with sharks and alligators in. And I think that's
Okay.
effectively what we've done here. So just to finish off the piece on the right, so for the Power BI dashboard, you can also use the same context-based ingress. For Delta sharing, we have
Okay.
a different set of IP ACLs, so you can set IP ACLs on the Delta share. So you just do something similar. They are different to the IP ACLs on the left, but they're specific to Delta sharing. Yeah, and then Power BI would you'd use the context-based ingress again to secure those.
All right. This is all context-based. Okay.
The only other thing that we could maybe mention is on your little sparkly AI box, we could add a reference to AI guardrails. So within Databricks, we have AI Gateway, and you can automatically configure AI guardrails for all of like your interactions with AI models. So trying to detect kind of like bad actors trying to do things with your models, essentially.
Oh, Nick, didn't you use this for the App First Summit last year?
Yeah, you can set up things like PII guardrails, like keywords that you don't allow, things like that.
And sorry, I can see one final thing that's written in the notes, Andy, if you want to mention that.
Oh yeah, I was trying to remember. Actually, two things I would call out. So firstly, often configuration drift is a real thing. The amount of times that an organization will set up all of this stuff really perfectly on day one, when they first go into production, and then like have no concept of like whether all of the controls are still in place 2 years later. Like have one of their admins just removed, like added, I don't know, their home address to the IP access list just because it makes their life easier or something like that. We have this thing within Databricks. It's actually a labs project called the security analysis tool. You can set this up and it will run and basically call the REST APIs for all of your workspaces and give you like a report that shows you where these controls are configured and where they're not. And it's really good for customers to keep on, like, not just like how secure was my workspace when I deployed it 4 years ago. It's like how secure is my workspaces today. I think the point I added was about ensuring that you're monitoring all of this as well. Like you probably want to know if someone is trying to brute force like your identity provider. So it's not just a case of configuring that, but also setting up alerts that says someone keeps trying to log in and they're failing authentication and stuff like that.
All right, Nick, do you want to add the security and was it static analysis security to what is it called? Sorry.
The drift, configuration drift.
Yeah, so you got configuration drift. You could do with the security analysis tool, and then also monitoring on system tables.
I don't know how to add that, guys.
I would just
giant box around it all.
I would just add it like at the top.
I wish I could just make it blurry. Wouldn't it's just you blur it out? Blurry.
Because I would just add something like here and just say like, can I be really like?
I'm just gonna hover around you.
Yeah, Nick, take the credit and pretend he's typing at the same time.
Something really passive aggressive like that.
Hey! Yeah. Okay. Okay, that's way better than what I would have done.
Right, should we make this like enormous? So I think that's a good selection of everything we've got. Like Andy said, like this is not every single Databricks security feature, but these are probably the main ones that apply to most people, kind of generic circumstances. Based on this, so we normally rate our architecture each month, but Nick, I feel like this month is actually quite competent, and these are the kind of things that people should actually be doing.
This is embarrassing because like this is the best one.
Yeah. It's fine. Next month it's just gonna be Andy talking sensible things, and Nick and I are gonna be fired.
I need to go back because I reckon you say this every time.
9 out of 10. It can't be 10 out of 10. It's never going to be 10 out of 10.
No, I think it's a 9 out of 10, especially we've put in front end private link, which I guess is not for everyone. It's only if your company super duper needs it. I know it would make this a 10. If you could draw an alligator on here, I think that would make it a 10. And then we can have the perfect architecture.
Actually, a 10, unfortunately, would be to delete the whole thing. Can't break into something that doesn't exist.
Yeah, excellent. I love it. It's an idea. Thank you so much for Andy for joining us today and also drawing an alligator on our diagram. Do you think it's a 9 or do you think the alligator pushes it over to a 10? I'm going to leave a link in the description to all of the things that we spoke about today, including that security analysis tool, but also the best practice guide as well. So if you want more detail on security for specific things, you can take a look there. Next month, we will be back with a regular episode where we go through a lot of the updates, including some of the ones from this month as well that we might have missed because it has been a bit of a quiet month. Until then, we'll see you next month. Thank you so much. Bye, bye, bye.
Stay safe out there.
Andy, you got to wave. You got to wave. Say bye.
Bye.
Yay, he did it. He did it.